Hi everyone, we're going to go ahead and take a look at chapter or lesson 8-2, adding and subtracting rational expressions. So this is an extension from what we did in 8-1 in that we multiplied and divided rational expressions. So the same rules apply when we go ahead and use fractions as we do when we add and subtract rational expressions. Oh, apparently that was the wrong button to press. Sorry about that. Generally, I do this at school when I have a second screen, so it's a different button I go ahead and do. So let me go ahead and get that PowerPoint back open. Um, All right, share screen. Let's go ahead and get started. So last time we're going to add and subtract this time compared to where we did multiplying and dividing. So one of the biggest things we're going to do is find LCMs, or least common multiple, which is different from a GCF or common multiple. We're looking for the smallest term or expression that our polynomials or denominators will multiply into.
So our first example is find the LCM of 15a squared bc cubed, 16b to the fifth c squared, and 20a cubed c to the sixth. So we're going to factor our first monomial, and we get 3 times 5 times a squared times b times c cubed. Next, we factor our second monomial and get 2 to the fourth, b to the fifth, and c squared. So as a reminder, 2 to the fourth is the same thing as 16. Then we're going to factor our third monomial, and we get 2 squared times 5 times a cubed times c to the sixth. So what we're seeing here with our constants or our numbers is that we're doing prime factorization. So we're trying to find the prime numbers to whatever power they may be that multiply into that number. So as we know, 4 times 5 is 20. So 4 is the same thing as 2 squared because that is the prime factorization. So our LCM is we're going to use the factor of the greatest number of times it appears. So that means I'm going to take 3 times 5 times 2 to the fourth times a cubed times b to the fifth times c to the sixth. This is going to be our largest common multiple, or least common multiple, I'm sorry, and it's 240 times a cubed, b to the fifth, c to the sixth. So the difference here is that we're looking for the least common multiple. What is the smallest number they all multiply into, compared to what we might also look is the least common denominator, which is where we're looking for what is the smallest multiple that multiplies in. So do remember LCM stands for least common multiple. So our answer again is 240 a cubed, b to the fifth, c to the sixth. We have one more example for least common multiple. We have x cubed minus x squared minus 2x, and x squared minus 4x plus 4. So these are going to be polynomials instead of monomials, and we're going to factor both of them first. So our first one factors into x times x plus 2 times x minus 1. They all three terms have an x in common, so they factored that out to get x squared minus x minus 2. And then went ahead and factored that quadratic to get x plus 1, x minus 2. Next, we factor the second polynomial, x squared minus 4x plus 4, and we get x minus 2 squared. So that means it's x minus 2 times x minus 2. So again, we're going to use each factor the greatest number of times it appears as a factor. So we're going to use x times x plus 1 times x minus 2 squared. We are going to go ahead and leave it in factored form so that we don't get confused. So do go ahead and do that. Leave it in factored form. Do not try to multiply through.
All right, so here is your first try. Find the LCM of 6x squared z y cubed, 9x cubed y squared z squared, and 4x squared z. Go ahead and pause the video, give yourself a chance to try it. All right, so you should go ahead and get C. 36 is the smallest number that they will all multiply into. And then again, you always just take the highest exponent for at least the least common multiple. So for the highest exponent for x is 3, y is 3, so and z is 2. Here's your next U try of finding the LCM of x cubed plus 2x squared minus 3x and x squared plus 6x plus 9. Go ahead and pause the video, give it a shot. And you should end up getting ax times x plus 3 squared times x minus 1. So to remember, you need to go ahead and factor out the GCF as possible, and then go ahead and factor the resulting quadratics into its two linear factors.
Our key concepts for today are going to be adding rational expressions and subtracting rational expressions. Our first one, adding rational expressions. To add rational expressions, find the least common denominator, or LCD, and rewrite each expression with the LCD and then add. So, for example, we have a over b and c over d. B and d both cannot be 0 because, again, we cannot have 0 in the denominator. So if I have a over b plus c over d, I'm going to have to go ahead and make those to have common denominators. So the first fraction becomes AD over BD plus BC over BD, which simplifies to AD plus BC all over BD. On the first fraction, what we multiply top and bottom to get like denominators is we multiply by D, and on the second one, we multiply by B to C and D to make sure that what we do to the top, we do to the bottom, so that we'd have like denominators. In subtracting rational expressions, this is very similar. To do so, we would find the least common denominator, rewrite each expression, and then subtract. So the only difference comes to in subtracting rational expressions, we subtract, and in adding, we add. Right. Example 2, we have 5a squared over 6b plus 9 over 14a squared b squared. So we're going to find the least common denominator. So on that means, well, for the first one, we need to go ahead and multiply by 7a squared b to the top and bottom. And for our second fraction, all we need to do is multiply by 3. So when we do that, we get 42a squared b squared is the LCD. And we end up with 35a to the 4th b over 42a squared b squared plus 27 over 42a squared b squared. We add the numerators as much as we can, and in this case, there are no like terms for us to combine, so our final answer simply is 35a to the 4th b plus 27 all over 42a squared b squared. All right. Example 2, check your progress. This is a DOL question, so you should go ahead and check it here before you do your DOL.
Do ignore
You're gonna add
the audio on that. This is a pre-recorded from last year, and I apparently skipped this one and deleted the recordings. So when you go ahead and do this one, you should
3x squared over 2y.
And again, it's just going to be that you need to make sure that you go ahead and find the LCM, which in this case, I would need to multiply the first equation by 6xy top and bottom. And that would be all I actually have to do because 12xy squared is the least common multiple.
Example 3, we're now going to use subtraction, and we're also going to have polynomial denominators. So x plus 10 over 3x minus 15 minus 3x plus 15 over 6x minus 30. Our first thing is to go ahead and factor the denominators to see what we have in common or what we might need. When we do this, we find that our first fraction, x plus 10 over 3x minus 15, our denominator is 3 times x minus 5. And our second fraction, 3x plus 15 all over 6x minus 30, our denominator really is 6 times x minus 5. So this one's pretty easy when we go ahead and look at it. 3 and 6 are very close. All we need to go ahead and do is multiply by 2, top and bottom on our first fraction, so that our least common denominator of 6 times x minus 3 can be achieved. When we do that, we're going to head and subtract the numerator. We are going to go ahead and try and simplify as much as possible here. So we are going to head and distribute that 2 to get 2x plus 20, and then we keep the minus 3x minus 15 all over 6 minus x minus 5. So then we're going to head and combine like terms, and we get negative x plus 5. When we simplify this, negative x plus 5 is the same thing as x minus 5 times negative 1. And when we do that, we would find that our two factors cancel out top and bottom, and we're left with negative 1/6 for our answer. So sometimes when we do simplify or when we add or subtract rational exponents with polynomials, we do get an actual number for our answer.
Here is your next u-try. You have x plus 5 over 2x minus 4 minus 3x plus 8 over 4x minus 8. So go ahead and simplify as possible, pause as needed. All right, so when you're working this one out, you should notice that you only need to multiply the first fraction by 2 top and bottom, and that will get you your like denominators. You also have the option of dividing by 2 top and bottom on the second fraction, but that might be easier to go ahead and do at the end depending on what we have. And you should find that we end up simplifying everything out, and you now are left with negative 1/4.
Example 4, complex fractions with different LCDs. So a complex fraction is where we have fractions within fractions. These are not as hard as they seem. They just look ugly, so that's why people are afraid of them, but they're actually pretty straightforward. So do remember when we divide fractions, we keep the first and flip the second. So we're going to go ahead and start with this. The LCD of the numerator is AB. The LCD of the denominator is B. So that is something we need to look at. In the numerator, we multiplied the first fraction by B, top and bottom, and the second fraction by A, top and bottom. For the denominator, we just multiplied by this 1. We changed that to B over B, which is still 1, but that is how we're going to rewrite it so that we have the least common denominator. So we're going to simplify the numerator and the denominator. And so our numerator is now b plus a over ab, and our denominator is 1 minus b over b. So we're going to write this as a division expression. So again, we keep our first fraction, or our numerator, b plus a over ab, and we're going to divide by 1 minus b over b. But as when we divide with fractions, we go ahead and flip the second, so it becomes b over 1 minus b. And now we're going to go ahead and multiply. They do cross out the like multiples, so if you notice, they both crossed out b, top and bottom, so that reduced down to 1. And we are now left with b plus a over 1 minus b, or a plus b minus over a minus ab. Both would be correct. One would just depend on how specific you would like your answer to be, or if we're trying to find our zeros or what values we can't have, would make a difference.
All right, here is your u-try. We have 1 over a minus 1 over b, all over 1 plus b over plus 1 over a. Go ahead and try this one. Pause the video as needed to give yourself time to try it. All right, so checking your answer, you should end up with D when you finally cancel everything out. So that is one option that we do have.
In our final example 5, we have complex fractions with the same LCD. So here we have 2 over x minus 1, all over 1 minus y minus 3 over x. So we're going to find the LCD of all the denominators, and it happens to be xy. So we're going to multiply everything by x over y, And when we do that, we end up getting 2y minus xy all over x minus 3y. And that is as simple as it gets, so that is simplified to what we'll get. 2y minus xy all over x minus 3y is our answer here for example 5.
Here is your last U try. Go ahead and try it out and see what you get. Pause the video as needed. And you should end up getting D 3b minus 4a over 2a minus 1. So that is our lesson that for adding and subtracting. So we will go ahead and continue with 7-3 or 8-3 next time. Hopefully this did help, and I should see you in class. I will see you next time.